Hello everyone, welcome to the next episode of Azure On Air. Today we have Sander van de Veld, who's an Azure IoT platform architect for Alten, who's specializing in designing and developing Internet of Things platforms. And he's an Microsoft certified Azure IoT developer as well. With his commendable contribution to the community, he's been awarded 6 times the Microsoft MVP award since 2017, and he also works closely together with Microsoft on new features and innovations. He's very interested in using new techniques but with interoperability and maintenance in mind, and he's very likely to learn every day and to share his experience with the budding community like us. I'm very excited to bring in Sander for the show. Hi, Sander.
Microsoft works together with partners regarding hardware. Devices, Microsoft normally works together with hardware partners. If you have devices somewhere in your factory or in your company on another place in the world, but it's not allowed directly to connect to the cloud. Hello, Amirta.
Yeah. Sander, let's give a heads up to the audience on what we're going to speak today. So, Sander and I, when we started connecting for the podcast, we just planned to speak on Azure IoT. Since Sander is he's an expert in the platform of Azure IoT platform. So, I just decided to have a topic around that so that Sander would throw us a lot of information on that. So, Sander, just give us a heads up on what you're going to talk.
Well, today we'll have a short introduction in Azure IoT, but from there we will talk about Azure IoT Edge and digital twins and everything in between.
Super. So, as you mentioned, a short introduction about Azure IoT. So, we would also like to hear it on your terms. How does this Azure IoT look in the eyes of Sander?
Well, the IoT platform or a IoT platform in general is made up out of three things. First of all, you have devices somewhere in the world, many devices. And these devices generate data. That data has to come into the cloud. Cloud is the second component, and each device needs a secure connection to drop off the telemetry and maybe also get some commands back if needed. It's a two-way communication. And lastly, based on that data, we want to have insights. So there will be some kind of reports or dashboards built on top of it to bring value.
Okay. So, having that spoken about, what are the Azure offerings that we have in terms of that, Sander?
Well, the Microsoft IoT offering is a very broad one. First of all, the most important thing is the cloud gateway. That's the endpoint in the world where the any device can drop off its telemetry. That means that each device has a so-called registration inside the IoT hub. IoT hub is the actual gateway resource. And with that registration comes security keys. So each device has a secure connection. Um, and we can see if a device is connected or not. And we also support a online offline scenario. Devices are not always connected. So if I have some information for that device to be picked up, for example, a change in the set point or a change in the send interval, um, I can put it in the IoT app, and if the device comes along, it can pick up those desired properties and work on the desired properties. And once they are accepted, it can be reported back in so-called reported properties. So that's the first and most important resource. And once the data comes in, well, from there, we can do a lot. We can go for alerting. That's also called the hot path. So, for example, we use Azure Stream Analytics, which is acting as a rule engine for incoming telemetry, and we can aggregate, we can filter, we can combine it, we can join it with other data, and on that we can use, for example, Logic Apps or Power BI to give real-time insights. And yeah, if we go to the other side, well, Microsoft works together with partners regarding hardware. Devices, Microsoft normally works together with hardware partners. Any device that you can come up with which has an internet connection, you probably can get it connected to the cloud. Microsoft also has this Azure Sphere offering. This is a device concept of a highly secure device. It doesn't trust anything. It doesn't trust itself. If it's there's a lot of gates in there to check if it's compromised, and if it's compromised, it will reset itself and go back to the latest installment of the software on it. That cannot be done on the device itself. It has to be done from the cloud. And if a number of devices have that same problem, then the whole family of devices is seen as compromised, and they will get reset all of them. So that's if you want to go for a really highly secure device, then maybe Azure Sphere is a solution for you.
Great. Great, Sandra. That was a clear explanation on what we asked for. And also, I'm curious to know about this edge compute. Can you help us understand what edge compute is and how does it facilitate in this Azure IoT platform?
Yeah. Well, edge compute. You have to think about some piece of logic, a PC, a laptop, an industrial device, or even a VM, which lives on the edge. That's the name, on the edge of the local network, and it has a secure connection to the cloud, to the IoT hub. This is a perfect way if you have devices somewhere in your factory or in your company on another place in the world, but it's not allowed directly to connect to the cloud. There are many devices which do not know the concept of internet, they don't know the concept of security, or they expose data which is sensitive. There's IP in there, or it's GDPR sensitive. Um, then you can use the edge compute as a man in the middle, but then in a positive way, which connects to the devices on the local network, does something with the data that's coming in, and tries to drop it off in the cloud if needed, based on the logic that you run on the edge.
That's nice. So you just mentioned that it's based on the data it's handling. So there might be the process of data handling, right? Can you just throw us some light on that?
Yeah, well, I already mentioned that it's quite common to work together if in the cloud with the IoT hub, that you want to react directly on data, that there are alerts. That's called the hot path, and that's typically done with Azure Stream Analytics together with Logic apps or other solutions like something with WebSockets. Hey, within a second or millisecond, near real time, you can react on incoming data. But on the other hand, there's maybe also coming in data which doesn't have value yet. There, it's telemetry. It's something that you think it's important, but well, it's not quite clear now. So what you typically do is you drop it off in some cold storage. That's called the cold path. and that could be just a data lake or blob storage. Or nowadays, what we see a lot is Azure Data Explorer, which is a perfect way to store huge amounts of data and to store it in a price wise way. And once that data is stored in your Azure Data Explorer, it's there. You can leave it there, or you can try to figure out and do some investigations on the data and try to figure out if there's a trend or an anomaly. And that's done with the custom query language. This is typically something done with a data scientist. And if a data scientist finds something which has value, there's a certain KPI found or an OEE, or some trend or anomaly is found, he or she can put it in a dashboard, and to make it more simple, accessible. I'm not really fond of querying data. If I want to have some graph or chart, I just want to click on a page, and it should be there. Well, and that's something that is called the warm path. So the raw data is aggregated, filtered, enriched on a daily basis, and then it's made available in some dashboarding. And because there's something done with that data, it's quite and it has to be accessible in some kind of dashboarding solution. This is mostly a more expensive solution, and the value of that data is temporary. You don't look at charts about production from 2 or 3 years ago. After a certain amount of months, you probably are not interested anymore. So then it's time to wipe it. That original data is still there. It's in the cold storage, so you can create it back. But warm path is mostly a, a time limited path. So those are the three pillars of handling data: the hot, the warm, and the cold path.
Nice. So, while speaking with you initially, Sandra, before the recording, we just got to understand the term digital twin. I just learned a new term called digital twin. So, can you just help me understand what it is so that the audience are also benefited?
Yes. Well, we just talked about the three pillars of handling data. That's because there are different personas, different users of data. And we have the stakeholder, the owner of the product, and he's interested in costs and earnings and KPIs. Well, that's something done in the warm path with, for example, Power BI. Um, and then there's the data scientist who wants to look at the raw data, and he's interested in really tinkering with each uh, data point that's coming in and try to see if it fits or doesn't fit in some trend. That's, for example, Azure Data Explorer. Um, and then we have the personas like an IoT engineer. He's responsible for the whole pipeline from telemetry, from device to storing the data in the cloud. Or we have the engineer of the device who wants to know about how a device is working. Well, those two personas are typically not really interested in the actual data, but in a more smooth, represented technical dashboard. Well, that could be done, for example, with Grafana. And then we have a person who has to make decisions based on the data that comes in, but he or she doesn't have the technical skills to actually know what's happening. So these people have to be helped with a simplified version of what's happening on the in the machine or the environment. And that's called a digital twin. A digital twin is a model, it's a representation of something that happens in the real world, but in a simplified way, mostly. It could be very technical, but most of the time it's just a simplified way. So that twin can show the current status of a machine, or you can enrich the current data that's coming in with some historical sense of data, something that happened in the past, or you can add to it predictions towards the future. And that's still, of course, from the concept that we're looking at a live representation of that device. Well, once you have that from one twin, from one device, well, most of the time devices are interrelated, and twins are also interrelated. They have a parent, like a machine is living on a production line, and a production line is living in a building, and a building is one of many buildings of the same company. So we can have a hierarchy. And for example, if a fire alarm goes on a certain machine, then probably you have to raise also an alarm on building level, or maybe even on premise level. So that's the concept of digital twins, and Microsoft offers Azure digital twins for that, like a beehive, a cloud of twins living together in this environment, and they are able to respond on the telemetry that comes in and other sources of data, and they can traverse through that graph of relationships. So if something happens with a certain sensor, that could be combined with data from another sensor, and then the parent could be alerted, and there's an alert on that level. So that's how digital twins work. And on top of that, well, you can do some nifty visualization, like 3D representation of a factory or an airplane, or a building with a group of people in there. And you could even try to work with 3D visualizations where you actually see things moving, just like in the real world. Yeah, well, that's up to your imagination. If you put a HoloLens on that, that would be really, really great.
Yeah, so that sounds really interesting, especially the last part which you mentioned about the 3D figuring and all that. I suppose people who are into IoT and who are trying to learn the term what digital twin is, just like me, would definitely love to experiment such things, Sander. So, apart from all these technicalities that you mentioned, we also get to know that you are consulting people who are up to with the IoT projects. Yeah, you are helping them at any stage of that project. Yeah, can you just give us some real time examples that you faced, or what are the benefits and when to use what? That would be more of an real time experience for us. Yeah.
The last couple of years we've done, well, for many years already, we've done a number of projects. And let me pick one or two of them. First of all, there was a company, and they have a crane, a mobile crane, and it's rented by companies who have to lift stuff from, for example, on a construction site. And those cranes, they have a certain reach, say 40 meters or 50 meters. So you hire a crane according to that reach. But the hiring company doesn't have that much of cranes. So sometimes people say, well, I have a load at 30 meters. And then the rental company says, well, I only have one device reaching 60 meters. You can have that one for the price of 30. But then you will see that in the end, there's always something to do at 60 meters. So that means more time, more stress on the operator because he's doing stuff which is not according to the offering, and there's some risk involved, of course. And well, the device will worn out more quickly. So what we did, we made the cranes cloud connected, and we set the limitation from the cloud. So from the cloud, a operator or somebody in the back office can say, okay, this crane can only operate up to 30 meters. So if the crane capable of doing 60 meters normally arrives at the building construction site, it's limited. And if they want to go beyond that 30 meters, they have to call the back office. There are some contracts involved, and then it can be changed live within seconds. So that's less stress for the operator and a better control on the wear and tear of that device of that crane. What's also done is sometimes not building parts are lifted, but people are lifted. There's a cage, and a person is put in that cage, and he can do some observations on a higher level. Um, and that means that everything has to go really slow because there's risk involved. That people are well um, projected. Uh, they are well, they can fall out of that cage. That's not what we want. So we have to build in the option from the cloud that we can operate that safety measure, and that made the cranes immediately more flexible. Our customer was able to sell more cranes because of that flexibility. The customers didn't have to choose exactly for one type of crane. They could use a more expensive one, but then have it rented in a more flexible way. And yeah, that's a really nice solution. And another example that's done recently. Um, One of our customers, it's all about cranes. They offer a solution for cranes put on at sea, offshore. Those cranes are used for building windmills, those electric windmills, um, and the parts are coming from a ship. Well, the problem is ships move; they go up and down due to the waves, and especially somewhere around to the winter time, the waves are so high that it's difficult to get data the parts from the ship without any risk. The ship moves up and down, so also the load goes up and down. That's really hard for a crane operator to get it off a ship. So what our customer has built is a device which can uh, be hooked on a crane as an extra hook. It's something like 12 meters high, and it can lift 600 or 1100 tons. That's the weight of multiple Boeing 747s. And it can expand and it can retract, and it will follow the movement of the ship. So if you're on a ship and the ship goes up and down, the hook of the crane also goes up and down. So from somebody on the ship, the hook is always on the same level. And our customer asked about, can we have the data from that hook, that um, It's from SQLize, and it's called the Heave Chief. Can we have data from the Heave Chief sent to the cloud? And there's a lot of data in there because there's lots of hydraulics, electronics, battery packs, Wi-Fi connections. They want to measure everything on that device. Think about 50 times a second, more than 3,000 data points. Um, so sending that to the cloud could be a challenge, because maybe there's no connection, we are at sea, or there's only a connection using a satellite solution. So what we built was, we collect all the data from the Heave Chief, but we don't send it directly to the cloud. Only once every 10 seconds we take one measurement, one one measurement, and we send it to the cloud just to have some dashboarding. But the raw data is all put in files on the edge device because we are using an edge device. So we have storage. And when there is connection, we use a data pump to move the files from the device, from the hook towards the cloud. And once it arrives, it will be unzipped, it will be opened, and the raw data will be put in an Azure Data Explorer solution. So we have a reliable solution and a cost-effective solution for that raw data, so it can be investigated later on. And our customer is really excited about it, because this is a really cost-effective way, and it can be used all over the world. And there's it's really flexible. It works with Wi-Fi or 4G, but it also works with a satellite connection, which is something that happens a lot in uh, in offshore solutions.
Brilliant, brilliant. So that is an amazing real-time use case that brought us to an interesting world of Azure IoT. So I'm really excited that so many learnings are up for us in the Azure IoT platform, and I'm also going to start my learning on that as well after this session. So thanks a lot, Sander. That was a very fruitful session. We had a lot of learnings, lot of understanding about what Azure IoT is and its branches around surrounding it. So, what are your thoughts about the beginners in the community? How do you want to help them? What are the tips that you could give them?
Well, if you're interested in IoT, in Azure IoT, there is a certification program from Microsoft. It's called the AZ220 Azure IoT Developer Specialty. So if you just Google for AZ220, you'll probably get to the resources. Um, Next to that, Microsoft has a wonderful portal. It's called MS Learn, Microsoft Learn. There you can find hundreds or thousands of learning modules, really nice modules with examples, and even in most of the cases, free Azure access. So you can actually try out what you have learned. But there's also a Q&A section there where you can ask questions, and I spent a fair amount of my time answering questions over there. I love to share my knowledge, and I want to be triggered by questions from others, so I learn also. And of course, I have a blog, so if you Google my name, you probably will find my blog, and I try to blog about Azure IoT in the broader sense. So if I learn something and I think, hey, this is interesting for others to know about, I probably will write about it or have written about it already.
That's amazing. So as you said, only when you are posted with questions you get to trigger and you learn a lot. So that was a wonderful lesson that you gave us in the end of the show. End of the show. So thanks for your time and thanks for sharing your knowledge with us, Sandra. We were extremely happy to host you, and I suppose the audience are also very excited to also learn more about this from your contribution in the show. Thank you. Thank you so much, Sander.
You're welcome. Thank you.
Covate.co